Okay, we're going to actually start section 2.2 with histograms, kind of a little of a background before we do the first one. The concept here, the frequency distribution is good, but a histogram is even better. It's kind of like a picture of the frequency distribution. Here is the definition. A histogram is a graph consisting of bars of equal width drawn adjacent to each other unless there's a gap in the data. The horizontal scale represents classes of quantitative data values, and the vertical scale represents frequencies. The heights of the bars correspond to frequency values. Okay, the important uses of a histogram. They visually display the shape or the distribution, shows the location of the center, and shows the spread of the data. It also will identify outliers. These are just important information to keep in mind as we progress through this section. Okay, this is problem number 1 of your class examples 2.2. The histogram to the right represents the weight in pounds of members of a certain high school programming team. What is the class width? What are the approximate lower and upper class limits of the first class? Well, the class width, it looks like we're going from 100 to 120, 120 to 140. So I would say the class width is what? What's the difference in 100 and 120? 140 and 120, 160 and 140. Looks like it is 20. What are the approximate lower and upper class limits of the first class? Well, it looks like the lower limit is what? 100? What would the upper limit be? Well, let's see. What happens if we put 120? Just keeping in mind what we already know about limits. They'd like that fine. Okay, so 100 to 120.